and good morning. Pour in some hot water. All right, we'll start with half a cup. All right, so here in init logging, I think I want to go a little bit further. There we go. Settings to log spec. That's what we need. So if a level, so if we enable tracing for SQLite, then let's set up some additional tracing. Okay, we can do that up here. That's fine. Hey, Sam. Happy Sunday. How are you? Good weekend so far? Oh, you had the flu for the past few days. Oh, ouch. Well, get some rest and get better. Well, I think we can configure logging with this or with this SQLite 3 config. To configure logging here. I think this is the wrong one. I think we just want config. Hmm. Fascinating. What is the difference between SQLite 3 config and DB config? Similar to SQLite 3 config, except that the changes apply to a single database connection. This is new. Let's see. New to me. This is not what I want, though. Wow. Okay. Config doesn't exist. I I don't believe it. It is provided to support rare applications with unusual needs. Hmm. Are we rare with unusual needs? I don't think we are. Where is this? Is hmm. Is it in the base version? It's not in the ext version. Okay, so we would have to do this from the application, not from the VFS. Okay, fine. Most of what we're doing here is via sqlite. I wonder if sqlite passes that through. Config, db config. Okay, these are not the ones we want. Here we go. This is what we want. Set up the process-wide SQLite error logging callback. Okay. Where do we start up? Let's see, here's the main function. And let's do that before we get into initializing everything. At this point, we could set up logging before we start to process commands. What was it? Trace. All right. Trace, and we want config log and our callback. Some SQLite 3 log. Oh, you're not gonna do that for me. Okay. What was the log level and the text? I don't think we have to return anything. No. I don't have logging set up for these. I wonder if I should. Let's just to see it work. Do like a E print line. There we go. Result is currently unused. Fine, it'll panic. I wonder what we're going to see. Look at that. Beautiful. Misuse at line blah. Oh, blah. SQLite, thank you. I wonder why it's invalid. And I don't know that I have that line. I have to figure out what version of SQLite I'm using. Is this the version info? Hmm. All right. I think this is really what we need, though. So if we're providing an invalid database connection pointer, why is it invalid? Really? Come on. Red underscore hitting escape. Come on. There we go. Save. We're doing here. This is sqlite 3 thread DB. Or does Pretzel Rocks? Do they have commands? No, they're in the channel. They should just respond to something like that. Um, Let's see if that helps at all. Because our use cases are subtly different. Invalid database connection pointer. That is so interesting. Why would our database pointer be invalid? Unless I'm storing it wrong? Unless it's, I don't know. Yeah, let's reduce the amount of spew. There. Invalid pointer. Where's the first place we see this happen? File pass through. We had a short read. This was a 21 that happened. Main DB. Got a 12 back. Is this just something that hmm, just wondering if it's a common state. So in this case, we want the journal pointer, which is 28. So it's not something that we're actually doing here. Something is calling 21, which was what, sync? Yeah. Something's trying to synchronize. And we just pass that through. File control. Result is 21. Oh, no. This is definitely us. Getting confused between 21. Is 21 the result? It must be the result. Let's look at the docs one more time. This was rescue light. Error code. Okay. All right. Let's rename that variable. Make this easier on my future self. Error 21. Great. Okay. So why is our database connection pointer invalid? I'm glad that we've seen this. It's going to be helpful. Here. So we do this here. DB appears to be invalid for some reason. I'm going to need to check on some stuff. Let's see. That. Okay. Now we have our pointer printed out. And setting 14 F4 044C0 14 F4 44C0. That is the same thing. Why is that not valid? Is it the wrong data? Am I passing a wrong kind of pointer in? To be continued. I need to check on. So technically, I have the hose running. I'm filling a basin, and I want to make sure it doesn't overfill. I will be back. Probably 2 to 3 minutes. Be right back. All right. Back. So is this even the right pointer? Where'd the music go? Uh, mm-hmm. All right. So we're passing the right, well, what we think is the right thing. What if it isn't? So this one's mutable pointer to sqlite 3, which is what I thought we had. That's not in the, let's see. Okay. Log bad connection. Log an error. And where does the exclamation get added? Under log message. All right. I don't really care that much where the exclamation is. Let's go back a little. Log bad connection. Where does this get used? This is where we are. 3 places. Oh, null, unopened, or invalid. And so in this case, if the open state is not sick, open, or busy, it's just in an invalid state. That's great. Sick, open, or busy, which means we have closed, error, and zombie. So it could be closed, could be error, could be zombie. I believe this is called from, let's see which one. Yes, this one. So it's not one, it's not the open variant. So it's not open, closed, sick, or busy. It's, wait. So we check for open, busy, sick. Oh, we're checking for open twice. Got it. So all we get is that it's invalid. Okay. So we know it's in one of the other three states. So it's either closed, error, or zombie. How do we know? Is this in open? What is this? No. SQLite 3, leave mutex and close zombie. I guess it could be closed. Let's review what we're trying to do here. At this point, this function control commit phase 2, I was considering that we would use this in order to get a pointer to the journal file. Now, the purpose is that in commit phase 2, we are currently within the transaction lock. So I was thinking that we would just add one additional lock, right? We would also get the read locks and then rename the file when we're rotating. So technically, we don't have to call this file control API. We could get the handle to the journal in another way. As we are abstracting it. All right. So ideally, this actually calls through file control. We pass the same thing through. Comment all of this out. Um, It's not return. Then the underlying function will get called after we do our bits. So really, in this case, we just want to add some locking. Does that differ? Let's say we didn't even have this. Okay, that goes away. We do nothing there. For the database is unlocked. So technically, we already know this because the wall log during the writing, it's in here somewhere. However, rotate wall, we could just find it from this. Shut down, no. Maybe here. Yes. So at this point, we're going to write the file header. And we'll end up rotating the wall log. At this point, we detect that the salt's changing on the file. And then we rotate the solved. Now, let's look at this from the other end. I've been looking at this from the end where we need to block the other threads from actually reading from the wrong file, the other processes from reading from the wrong file. But what if we just saw the error and fixed it? So what we are seeing is that we'll get a 522 here. And it could be that, not the 522. Well, in this case, it's likely just fine, because the journal file doesn't have anything in it. Once we get a little further and we actually cause an error, did it succeed? It did pass. Because what I think is happening is that the wall log gets rotated in process A, and then process B tries to read from it, not knowing that it's been renamed, that it's in a different location. So we should be able to say, catch the read error and look to see if the wall log's been rotated. And if so, use that file. To calm some of these error logs, we did comment quite a bit out. Let's see what still happens. Okay, underlying file control. I want to ignore file control for a moment. It was fun, but didn't quite give much. Fastro67, thank you for the follow. Okay. We're doing some inserts and whatnot, but we do not have enough chatter happening. Let's increase the chatter. There we go. Let's get that failure happening. There we go. Not a database. File is not a database. I wonder why. Look, something just got renamed. That's probably because it was shutting down, though. Main DP, result 5. Let's see, in this case, one of the processes is just waiting over and over and over again because it can't get a lock. It's trying to get a shared memory lock. See, one of the processes looks like it finishes. The other one says insert. Look at this error here. This is new to us. Insert into notes, blah, blah, blah. File is not a database. Probably because of this rotation. This is new. This is nice to see. So we do see that it's attempting to insert, but it can't for some reason. I want to see that with more log lines. Okay, let's find the error. Looking at the left side here, there's a lot that happens. I should have checked to see, did it succeed or fail? Didn't even look. Just figured it was an error. Let's see. No, it says it failed. Shutting down. Okay. Hmm. System I/O failure. Disk I/O failure. That's different. Hmm. Okay. That's different. Let's chase that one later. It passed. Wow. Okay. Good job. What did I? Oh, I hit tilde. Passed again. Is it because of the logging? So if we log, that doesn't happen. And it passed again. And let's just crank up the heat. Let's add the two threads to the party. Okay, not a database. Good. Error 26. Same error. Okay, great. Now can we do the same thing with tracing? One failed. Good. And how far back was the error? That seems like it's too far back. Rotating wall log. And back to the end. One failed. Not a database. Good. Same ghost we're chasing. I did a wall log rotation. I'm surprised. This is many, many, many more pages. Why would it write so much? Try again. Failed. Shutting down. System I/O failure. Disk I/O failure. The error must be getting dropped in the middle of this text because I keep scanning the left side and I'm not seeing it. What do we do? We don't know exactly where the fault is happening. I have some guesses. That's a lot of tracing. Now, this is mostly tracing for shared memory barriers and file control, shared memory locks, truncate. Oh, truncate received a size? Oh, but that's for the main DB. How is that wired up for the main DB? Okay, we just passed it through. It's fine then. All right, let's put this back to debug. Let's comment. So at least this way we got to see the error. I like that. I want to hang on to that. Get last error has been called. All right, this is result 522. So we got a short read on a wall log. Okay, like these three things together are so very sus. Okay, short read on the wall log. Now, underlying file or mount, and it's trying to read at a couple megs in. It wants to read a database page. Okay. Maybe it's this. Let's add a little bit more. So wall log short read. Here's read. Now, if we get a short read, let's check to see if our file exists. So what we will get back from this is the result, or the return code, result code, whatever it is. Good. So if it's 522, let's use the IO short. And 522. Great. Because if this is the case, then we can just open the new one, right? We can switch. Self.state. I think we might want state to do this, or shared state. Most of these just pass through. Yeah, let's do that. Let's just do that on state. Fix rug pull. Okay. All right. Just want to see some information. So at this point, we don't think that the wall log has been rotated, but some other process has rotated the wall log. Check. But if we open it, we'll have to basically say we never write to it. We need some way of actually opening the right one at some point. Maybe we have two open. It's not a bad idea. Keep track of where the reads and writes are happening. Kind of salt to position in disk. Well, let's see if this is what's happening. Bug-driven development. Here we go. Hmm. What is that file name going to be? I don't know what the salted file name is. I think we had a name for that. File header. We had a function to generate that. Where does this get called? File path. Where is this? Rotate wall. It's a result. All right. Just debugging, tossing a ton of unwraps in there when they shouldn't be unwraps in this code. Not in this area. All right. Does the path exist? The newly salted path does not exist. Oy. Okay. Weird. I gotta go check on that. Basin again. I will return. Oh, and thank you for the call. Thank you for the follow, Comrades all. All right. I'll be right back. Probably, I don't know, 5 or 10 minutes. It's probably getting to the point where The next stage is ready. All right. Give me a couple. Interesting. Let's add a little bit more information. That, and I have to check on the basin again in 20 minutes. It's getting close. It's getting close. Not getting the short read this time. But it's saying it's not a database. 26. Let's try again. Wait, did it check to see if that path exists? I thought we were salting that. We are. I gave the wrong one. Path exists. Let's also do the possible path. And we are checking to see if the possible path exists. Let's rename that to salted path. And then we will also check to see whether or not the file path exists. And maybe change this to wall. Again, Still seeing just one get starved. We didn't get a 522 that time. We didn't the past couple times. So what are we seeing then? Okay, last error. This guy error, 522. Well, okay, this time we saw a short read. Salted wall path does not exist. Wall log path does exist. But we had a short read on it. 522. Why? So the offset is at 2.4 megs, approximate. And got rolled later. Outlets arena TDs. A couple things that we know. We know that, we have this written down. Sometimes I feel like I'm going to. So we get file is not of database. Only happens when two processes, when, say, more than one process. I think this is, let's remove the question marks. One process is starved of wall log time. Yes. Do we get the same pointer to the file name across X open calls? Not sure what that means. The short does not happen if. Yes, okay. So if this code is commented out, does not happen. So we know that it's related to the wall logs rotating. What else do we know? Let's get a little bit more info. We're having this happen in multiple ways. In one case, we get a short read. In other cases, we don't. So when does it have, like, what do we see when it's not a short read? Yeah, like maybe this one. Because maybe getting more than one SkyO error. Nope, this was a short read. Okay, the wall log path exists. the other one does not. Why does the other one not exist? Is the number wrong? See, look. Look at this. So in this case, the wall log number was 250,467, 3280, and 3281. So the one that was rotated is actually the previous one. So it knew. It knew about this. Like this, it's trying to read the next one. Oh, that's interesting. How serendipitous that this happens right above it. And why would it try to read if why was this one rotated? Why was this one renamed? Okay, wall rotate wall beginning. The right is going to 0. We're just starting to write again at the beginning. What? Seasoning is changing to 82? Why 82? What happened to 81? Here's 81. So we have 80, 81, 82. Huh. What could cause this? It is a mystery. So we have 3 different salts within 10 log lines. And it's going straight from 80 to 82. Wait, we rotate end here, rotate begin, end, begin, end. What? Renaming that to 80, but then we're saying that 81 does not exist. How do we skip 2? 80. Okay, here's a renaming. Here's a renaming. But in this case, we're renaming to 80. And in this case, we're renaming to 80. Bum, bum, bum. When we rename, we need to check the start of the file. So why is this one renaming here? It's just going to 0. Yeah, so in this case, some process went from 80 to 81 and then rotates. So 80 is left behind. Right, we'll create the wall log, salted wall log. And then it ends the rotation. All right, going to 0. Then we're going to 0 again. What is the point of having two processes write data to the header? 32 bytes here, and offset 0, and 32 bytes here at offset 0. Now, in the first case, we see that the seasoning is changing. And we're going from 80 to 81 when we write to 0. And then here, seasoning is changing. We're going from 80 to 82. And this is just sqlite trying to write to that first couple bytes of the file. So it's actually trying to write. It did that. It's like, oh, no. We're going from 80 to 81 to 82 very quickly. I say very quickly, but who knows? We could have written, 100 megs in this time. Okay, but what we see is that we go from 80 to 81, 80 to 82. So we don't know at this point that the previous wall log was written to 81. We need to just have a previous be like a -1 in this case. So our seasoning is changing. Our previous one was not 80, it was 81. Oh, weird. How would it not know this? Or how can we keep this up to date? We could look at the frame headers. Unless it's just been starved for data forever because of the sleeps. And it missed an entire wall log. I guess that's possible. Ah, and check the basin. Again, I'll be right back. The to salt value copied from the wall file header. Interesting. Maybe we grab that. When does this change? That's at 32 to 39. Is that even useful? I guess this is useful for knowing what the current one is. Because if, let's say, you have two processes, and one is basically doing all the work, inserting a ton of data, and the other one just has as much data, and like on our gauntlet test. But process one does everything first, does the wall log rotation, and then process two is also told to go back to the beginning of the file. Use this. And we'll keep that in the back of our head. Wall logs. These 8 bytes are never read nor written by sqlite, since some VFSs might implement locks using mandatory file locks. They're never read nor written. And this is just the wall index locks. Interesting. Locking matrix. Access is coordinated in wall mode by using the legacy delete mode locks controlled by the xlock and xunlock methods. Okay. And the wall locks controlled by the xshunlock method of the object. Delete mode locks are stored in the lock byte page of the main database file. SQLite lock shared and SQLite lock exclusive are factors for wall mode databases. Wall mode locks are described above. Okay. And I feel like we've already read some of this. Lock exclusive connections from the exclusive lock change in between wall mode and any of the various rollback modes. All right. So just like before, there's shared, exclusive. Write locks are only taken exclusively. Read locks, maybe either shared or exclusive. When a connection holds a shared lock, that is a promise by the connection that it will use the wall and not the database file for any database pages that are modified by the first read, mark, and entries in the wall. I must ensure that there are no locks on wall read log n for n greater than 0, because such locks indicate that some other connection is still using the yes. And by us waiting for a truncation, we basically do this. We because sqlite only starts writing at the beginning of the file again if it is resetting the wall. That's this here. After a complete checkpoint, if no other connections are in transactions that use the write ahead log, then subsequent write transactions can overwrite the wall file from the beginning. Salt is incremented and salt2 is randomized. Yeah. So I don't think we have to get into locking these values. But it does seem as though we need to be able to keep the DB up to date. Sorry, the salt more relevant. So what are we seeing? Shared memory locks. Okay. Start inserting. And then salt changes. The write's going to 0. Renaming. No, I didn't see like a salt going to 0. That these two are paired, but this one's all alone. Grab these. Rotate while ending. Wait, where did beginning happen? Oh, really? Now we did a full sync. So we sync, we close. I think by this time, though, I added this thinking, let's just do it. It should be nearly free. So at this point, we're writing the file header, which means that, oh, does it? Yes, yes, of course. Whatever mutation happens, a sync happens as well, so we don't have to do that. We close the file because after every transaction, the file is synced. So we don't have to do this. We rotate the wall. So we underlying file close. Could a path rename? Oh yes. What if it already exists? Placing the original if it exists. Hmm. So this function is called with what it believes the previous salt is. Let's close. Mm. No, when we're closing, that's fine. Who calls close though? Does shutdown call close? Oh no, no, this is SQLite calling close on the connection. Ranger the Good. Thank you for the follow. Now, what if it exists? Okay, let's do this again now that I've removed the sync bits. I'm concerned that the sync bits were causing unnecessary contention. Okay, still failed. Great. Beginning, ending. Look at that. Nice and tight. Beginning, ending. Okay, we start at the beginning. Lots of sleeping because there's contention. It's waiting for the logs. And we see that the right is going to 0. The rotate. Okay. Gonna grab this. Replace the previous set of bits there. There, if we just rename it to call it the log file, we get better coloring. Okay. So we rotate it. Then there's some contention. No. I lost where it was. It was time 26, 623. Oh, here. Okay. Great. Shared memory lock. Salted. Does the path exist? And disk IO error. Yeah. This one is actually kind of nice. See, we didn't have any other rotations, did we? No. No other rotations. Happened fairly early on. We have one rotation here, and then an error happens. All right. So 0080 does a rotation. It rotates. So we go from 1502 to 1503. Okay. Yep, there's 1502. Putting the old one aside. And then the next one, or rather, whoever got the short read, salted wall log did not exist, but I think that's 1503 because it knows about the change. Maybe it's the same process. And then it tries to read. But this number here, see, underlying file 50080. Okay, that's our shared state. But it's only shared state for threads, not shared state for processes. So 6910 is different than this guy. So this one got the short read. So some other process. Check to see, does that exist? Because it has the new salt. That's what's getting me here. How does the other process know that it's got the new salt? Maybe from the shared memory. But where would it have told us about that? I have no idea. Somehow it knows about this. Maybe it read some data, but I thought we were logging loudly whenever a salt changed. Say, does it exist? And then just a little bit later, see that, hey, some seasoning is changing. We're going from 1502 to 1504. Fascinating. Well, there's nothing that says you can't create wall logs very quickly. Right. But what gets me is the skipping here. Why did we skip 1503? 1504, 1502. So this one definitely goes past a number. Grab this too. To the error. Okay, we should have the benchy error in there twice. Here. Good. So I believe this here is because they were told to shut down. We have a write going to 0, just 32 bytes. Same here. And then we get wall log rotation. How large are those files? They've got some data in them, 2, 4, and 5. Where's 3? That's unsettling. I know it exists. Oh, all right. I'm gonna have to think on this. Staring at it on stream isn't gonna help. I think I might go get a pen and paper. So I'm gonna run. Who shall we raid today? You have a wonderful weekend. Till next time. Bye bye.